Hi, everyone, and thanks for taking the time to join our session today, where we're going to be talking about new innovations on Azure Database for MySQL and PostgreSQL to turbocharge app development. My name is Andrea Lamb, and I'm a Senior Program Manager on the Azure Database for MySQL and MariaDB team. Personally, my favorite replication feature is really GTIDs. What about you, Lucas? What do you like about Postgres?
Yeah, thank you, Andrea. So I love JSONB. It's the best way to store unstructured document data in Postgres. My name is Lucas Fiddle. I'm a Senior PM on the Azure Database for Postgres team. And today we have a few exciting things we want to share with you. First of all, I want to share something with you, like kind of how our team thinks, right? And so the things we really care about in our team is we care about being open. You can see here the MySQL Dolphin. We care about being cloudy. Obviously, we're in the cloud, right? We run our services on Azure. We can see that here with the Postgres Elephant. And then we care about being magical. The kind of icon on the right is our own creation. It's the alicorn that represents the Postgres Hyperscale Citus extension. All right. Now, let's take a look at what we're going to talk about today. So there's 4 things we want to share with you. There's a few new announcements that we have here on the open source databases, and we'll talk about that first. Then we'll take a look at a resilient app that we built with Postgres. After that, we'll take a look at the simplified deployment using the new deployment options we're introducing with MySQL. And last but not least, we'll take a look at effective migrations. First of all, let's take a look at kind of, what have we added to our services in the recent past. So first of all, on the security side, we've added key features such as Azure AD authentication, which lets you sign into your database without using a password. We've also added custom managed key encryption, which lets you use your own encryption key. Both of these features have recently been GA'd and are available for the single server options. And then next, we've also added 2 additional compliance features for infrastructure double encryption and minimum TLS version support to make sure you can meet your compliance requirements. We've also made investments in performance. So obviously you have read replica functionality in our services, and we also have the intelligent performance features to let you automatically look at which queries are running on the database, and then we suggest which indexes should be created for you. And last but not least, manageability is key for us. So we now support reserved instance pricing for all our G8 services. We also have the storage auto-grow functionality, so you're not going to hit the outer disk limits. It's going to grow automatically. And today, we're in 50 regions. We're trusted by many companies. For example, some of the names you might recognize are HSBC, T-Mobile, Cloud9, the esports company, and JFrog. And we actually have a case study with Cloud9 that we also recently published. We have a link to that at the end. Now, the main thing I want to talk about today is the deployment options for MySQL and Postgres. So deployment option essentially is, a certain architecture, a certain way of running the Postgres or MySQL service in Azure. And so today we have what we call the single server option. These are enterprise-ready, fully managed open source engines that we manage on your behalf in Azure. We also have the Postgres Hyperscale option that lets you run Postgres that scales in the cloud without having to worry about you can scale to many, many terabytes of data, hundreds of terabytes of data, without having to worry about all the details of how that works. Now, today, we are excited to introduce 2 new deployment options, and our team worked really hard on this, so I'm really excited today to share this with you. First of all, we have the flexible server option. Today's talk is actually mostly going to be focused on that. The flexible server option is maximum control with a simplified developer experience. And flexible server is available in public preview for both MySQL and Postgres starting today. Second of all, we have what we call Azure Arc-enabled Postgres Hyperscale. This is a Postgres Hyperscale option that runs in your own environment, like in your on-premise data center or in other clouds. And it lets you use the same Postgres Hyperscale features that you have in Azure using other clouds. If you're interested in this, there was a session previously, and you can take a look at that on Azure Arc Data Services, which also talks about Postgres Hyperscale. All right, so today we're going to take a look at the flexible server option. So flexible server, there's a few key things I want to mention, and then we can jump into a demo. So first of all, one of the main aspects here is about giving you more control for your databases. So for example, we've taken a look at how we integrate with VNet in Azure, and you now have more control over that VNet integration and the network isolation that comes with it. And we're going to show you that in the demo as well. We also have more server parameters that you can use for fine-grained tuning, such as max connections. And also, we have the custom maintenance window functionality. This lets you choose your maintenance window so that you can make sure that maintenance for security updates runs outside of business hours and your database is up and running. Next, let's talk about resilient apps. So resilient apps is the notion that you can build apps across availability zone. An application obviously needs a database. And so with the flexible server announcement, we're also introducing the support for availability zones for the Postgres and MySQL flexible server options. That means you have the option of Stonedown and HA. You essentially get fast failovers with zero data loss. So that means if there is a failure in a certain availability zone or on a server, it automatically fails over to an already running secondary. Next, we also have the option to co-locate the application and the database in the same zone. This lets you ensure that you have the best latency, and queries that are very fast can run even faster. Last but not least, we care about the simplified developer experience. So we actually took a look at every single screen, at every single CLI command, and we made sure that it's simple and easy to use end-to-end for creating, provisioning, and managing your databases. We're also, of course, still fully compatible with Community, MySQL, and Postgres, so you can make sure that when you have an application running with Postgres or MySQL, that it will continue to work the same way as you would expect. And then we're also introducing some new cost optimization options, such as stop-start functionality for Postgres and MySQL, and we're introducing the new burstable server option that Andrea will talk about later. Now, let's go over to a demo, and let's take a look at how we can build a resilient app with Flexible Server. Today, we're going to take a look at the resilient architecture for Tailwind Traders. Tailwind Traders is a hardware store that uses Postgres for its inventory system. On the left side, you can see that they use AKS in its own resilient configuration. We have a load balancer, not pictured here, and we have 2 pods running, 1 in each zone. You can also see that they want to use Flexible Server with synchronous replication to have a Postgres server in each zone to protect against zone failures. Let's take a look at how this looks like in the Azure portal. You can see here that we have an AKS cluster already deployed, and we also have a virtual network. Now in this virtual network, we can see that we have 2 subnets configured. The first subnet is the default subnet, which is used for AKS, and the second subnet is a dedicated subnet just for Postgres. Now this dedicated subnet is using VNet delegation. You can see here that we've selected the Flexible Server service. Let's now connect to our AKS cluster, and let's make sure we have everything up and running there correctly. For that, we'll get the connection information using the portal, and we'll copy these over into a Cloud Shell instance that we already have running. All right, and now I'm going to copy the credentials. This is configuring the kubectl command, which I can use to connect to my cluster. You can see here that right now, no pods are running just yet. Now, what we need to do next is we need to actually provision our database. So let's go over to the Azure Database deployment options. And here we can see our 4 options, the 2 new ones that got announced today, which is Flexible Server and Azure Arc Enabled Postgres Hyperscale. For this demo, we'll focus on the Flexible Server. So we'll create a new Flexible Server now. You can see here that we have a choice of, our subscription, our resource group. We'll pick the Tailwind Traders resource group. Now, let me continue by choosing the server name. For server name, I'm going to use Tailwind AppDB, and I'm also going to make sure that I pick the same region as my AKS cluster, which is East US 2. Now, I could choose an availability zone here, but to keep things simple, we chose new preference for now. This will automatically assign a zone. Now, let's take a look at the different server types. So we have 3 server types here: burstable, general purpose, and memory optimized. And you can also see that I can choose between different server sizes. These match public VM names, so it's easy to find exact details like IOPS or storage bandwidth. We'll increase our storage size a bit for more IOPS, and then we'll now enable the Sonar and HA option. This Sonar and HA option makes sure that you have a second database server running all the time that is ready to take over in a moment's notice. Let's take a look at the Postgres version. So you can see here we have a choice between 11 and 12. I care about the latest Postgres features, so I use 12. We'll now pick our username and password. Pretty straightforward. I'll just, pick a somewhat safe password here for this demo. And then let's go to networking. So on the networking side, I have a choice between public and private access. For private access, we can choose our VNet again. You can see here that we, essentially can search for all the VNets in the same region. And I can choose the Postgres subnet as delegated. Right now, this delegation has to happen ahead of time. Now a server is ready to create, so let's go ahead. Now the creation will take a little bit, so let's switch over to a ready provisioned server so we can continue with the demo here. Now this server is already provisioned, it's in the same resource group, and it's also configured for this, the same virtual network. Now let me copy the connection string here, and we'll start our app with that. Over in a Cloud Shell, I already have prepared a YAML file that has the details of for the deployment of 2 pods, 1 in each zone, and that takes the database URL to configure the database connection. You can see here that I do need to substitute my password. I didn't pick the most secure password because this is a private connection, so feel free to take a look at that. You're not going to be able to connect. Then the other thing to mention here is that we have 2 pods running, and they're using anti-affinity to place them on 2 different nodes. And with this AKS configuration here, it's actually 2 different zones. All right, now you can see I've done my deployment. My 2 pods are already running. I also have a load balancer configured that was provisioned before, and I can now connect to this load balancer to connect to my app. And that means I can have a public connection for the web traffic, but I have a fully private connection between the database and the application. You can see here now this shows us the IP address that we're connected to, 10.241.0.4, and that's essentially the internal IP address of our database server. Now let's take a look here at the high availability configuration. You can see here we have the primary zone 1 and standby zone 2 configured. You can see zone 1 HA option is enabled. So that means we successfully have our 2 zones configured, and we have high availability ready to go. Let's illustrate how this would look like in a failure scenario. So for that, let's first confirm that our AKS pods are also running in 2 different nodes. You can see here one runs in node 0, the other one in node 1. So that would also be ready to be zone resilient. For now, let's focus on the database. So here you can see that we're going to run this AZ rest command, which is, it's a bit long right now. We're working to add a convenient CLI command for this, but you can test the failover using this command. And essentially what this does is it switches over to the secondary in the other zone. Now let's run this command. And whilst this command is running, this will take about 60 seconds. So let's go over to our maintenance schedule here to illustrate how you can configure for maintenance updates. So you have the choice here between a system managed schedule and a custom schedule. This applies for things like security updates or Postgres minor version upgrades. I can pick the day of the week. For example, I could choose, since we're a hardware store, I might choose something during the night. This hardware store is in Pacific time, so I'll pick Monday. I'll pick maybe 7 a.m. UTC, which is midnight. And that's, should be a good time for any maintenance that needs to run. When you have maintenance configured, this also shows up in Azure Service Health, so you get notification when the maintenance is scheduled. Perfect. All right, now let's take a look at our application and see if it's working. So we can see the database itself is still updating here. Let's take a look at the application. And we can see here that looks like that's taking a moment. And there we go. Okay, so right now we're in the state where we're failing over to that second server, and you can see that right now the server this is the old server, the 0.4 server, still refusing connections. Oh, and there we go. So now you can see that the connection switched over to the 0.7 server, and this completed within 60 seconds. We didn't have to change anything on the application configuration. It was, essentially just a retry, and then it worked again. And here's what we essentially tried to simulate, right? We tried to simulate a zone failure. So that means that when the zone 1 fails, the zone 2 is ready to take over, and you don't have to do anything for it. That happens automatically. Perfect. So now to summarize, we successfully built a resilient app. Let's switch back to our presentation so we can take a look at a few more details on the architecture. Perfect. Now we can see here the flexible server architecture. As we saw in a demo just now, we have different availability zones that the flexible server interacts with. Here we see the east-to-west zone. We can see that we deploy a Linux virtual machine into availability zone 1 in this example. Now, you might be surprised by our choice of Linux here, but we've actually seen that MySQL and Postgres are more compatible with Linux. For example, Postgres extensions, it's easier for us to support some of them on Linux. And so the new flexible server offering runs on a Linux virtual machine. You can also see that your data is stored on a premium storage option here, and that this is a fully managed flexible server service, so you don't need to worry about security updates or anything like that. Now you can also see here, as we saw in the demo, we can connect with AKS, we can also connect with Azure VMs or App Service, and all of these options provide integrations with the availability zones, so you can co-locate your app in your database if you'd like. Obviously, we also have full support for point-in-time restore capabilities. Now, the demo we looked at, we had a zone redundant architecture. So we essentially run 2 copies of this architecture, 1 in each zone. And we use synchronous replication to replicate the data from availability zone 1 to availability zone 2. This is very important so that, if the zone 1 fails, we can automatically switch over to the second zone. And with that, we're going to switch over to a demo of a simplified deployment of flexible server with MySQL. Over to you, Andrea.
All right, so in my demo today, I really wanted to show you guys some of the great improvements that our team has been making in terms of trying to simplify the developer experience. So let's start off this demo in WordPress. Now, for many of you who aren't familiar with WordPress, it is a very popular blogging platform that can be used to stand up blogs very quickly. And what WordPress does is it hosts its data within MySQL. And so this is used for the posts as well as any images that any of the blogs may actually need to provide. And so what I plan on doing is to actually create an Azure Database for MySQL flexible server using the Azure CLI. And so let's quickly switch over to that. And I wanted to demonstrate some of the great work that our team has been doing to try to simplify this experience. So let's pass in the AZ MySQL flexible server create command. And this is going to basically auto-generate as much as we can on your behalf. And this includes the resource group name, server name, username, and password. And of course, you want to make note of that for later on. And so let me highlight here in the resource group that's been auto-generated. And like we mentioned earlier, we really want to provide you a secure from day zero sort of experience. So this command is also going to create a virtual network highlighted here in the center of your screen. And it's also going to create a subnet. This subnet then gets delegated to be used with flexible servers for MySQL, highlighted here in the center of your screen as well. And as I mentioned earlier, one of the other things we're going to do is auto-generate the server name on your behalf, highlighted here as well. Lastly, I also want to mention we do also pick some smart defaults for you, and this includes starting you off on the lowest pricing available for flexible server, and that's in our burstable compute tier, and I've highlighted that here in the center of your screen. And so this is going to take a couple minutes to run, but essentially we really just want to show some of the great improvements we've been making to simplify this whole experience. And so of course all of these parameters can be overwritten if you do want to specify your own parameters. For example, maybe the username, you have a specific one you like to use. Also wanted to mention that we create a blank MySQL database for you. This is used for something like WordPress that needs a blank database there in order to install its software. And so this is what the output actually looks like. I ran this command earlier before the session, so you can see here we provide you with the connection string, and so you need that to obviously connect to your server later on. And like I mentioned earlier, we also want to auto-generate everything that we can. So this includes the password. Of course, you can override that later or pass in a password when you create it to be one that you like to use. And then also the username. And so we try to think of some clever usernames as well. So switching back over to the Azure portal, I wanted to show you what the experience looks like in the portal for some of the other things that we've really been trying to work on. And so that's the WordPress instance we're going to connect to later. But let's look at the flexible server that I've created. So within the Azure portal, a ton of different things that you can do include stopping your server. And so when you click stop, you're presented with a warning as shown here. And so what this does is it stops your server for up to 7 days. And so stop is really great for those of you who want to optimize your costs and you have apps that maybe don't need to run all week. You can stop them over the weekend and save some money there. Now switching over to the compute and storage page here, I got that from the left nav. You can see in the center of your screen that there are 3 different compute tiers that we do offer for flexible server. The first is the burstable tier, and this supports up to 1 to 2 vCores. And this is really great for those bursty workloads that you may have. Maybe you're a teacher and you have students logging on, maybe mostly in the beginning of the day. You don't see much traffic through the rest of the day. Burstable might be a really good tier for you to create your server on because you're paying a lower cost, and at the same time, it kind of fits those types of bursty workloads that you have. Otherwise, we have the general purpose and memory optimized tiers, which do provide you with a consistent CPU that you can use for every other type of workload that you may have for MySQL or Postgres. And so other things that you can do within this page here is actually scale any of your compute that you have. So if you wanted to change the vCores on your server, what you're going to do is actually use the compute size dropdown. And so you can see from this list, we're actually using Azure VMs. And so by changing the VMs, you're actually also changing the vCores as well as the memory allocated to your server. Other things you can change include the storage size here in the middle of your screen on the slider, as well as backups. And so you can change your backup retention period up to 35 days. Inside the portal, I also wanted to highlight some of the other great work our team has been doing to expose more and more server parameters. So I get there from the left navigation as well. And you can see here in the center of your screen, there's a pretty large table, and this includes all the server parameters that you can tune. And so to change any of these server parameters, you change the value in the dropdown or pass in a value by typing. And then once you're done, you hit the save button at the very top of the page. So let's change audit logs. And then I'm going to hit discard just for the sake of time, but you can make many changes using the Azure portal and even the Azure CLI. So the next thing I want to do is now update the WordPress that I showed you earlier to point to a flexible server. So to do this, I'm actually going to go to the WordPress instance and then go to the configuration page. From the configuration page, there's a ton of different things you can do, and this includes updating the connection string. So in the center of your screen, you can see the database information here. I'm going to click on Advanced Edit, and then I'm going to update the connection string to now point to that flexible server we were just looking at. So you can see here the database host is actually pointing to a different server. Right now it's pointing to a single server that I actually have available. So let's change that really quickly. So it should be Andrea Ignite Flexible Server. Actually, I think I called that Flex. So we'll update that. And then the next thing I want to do is update the username. So you can see here I have an @server name, and this tells me that this is actually connected to a single server. And so flexible server doesn't actually require the @server name, so we get rid of that. Check for anything else that needs to be changed and hit OK. The next thing I'm going to do is hit save, and what this does is it restarts the application and applies the settings that we changed. Obviously this is changing the database. So now it's done, let's switch back to WordPress. And within WordPress, I'm going to refresh it a couple times to make sure it's actually connecting to that single server. And so refresh, perfect. Now we're connected. All right, so now that you've learned about all the great things that you could do with Flexible Server in the Azure CLI, you're now probably wondering, how do you get your data into the Flexible Server service? So we have a ton of different options available. First, you're going to really assess your data to actually understand how much data you want to bring from on-premises or from your virtual machine hosted in Azure or on a different cloud provider. And once you've decided what data you actually want to bring over into your flexible server, you then migrate the schema. From there, you have three different options. The first is to do a offline migration using dump and restore, and that can be using the Postgres native PG dump and restore or MySQL dump and restore, as well as any third-party tools or open source tooling available to you. Another option is to use the native logical replication that's supported by both the MySQL and Postgres engines, and this is an online migration because the data is continuously replicated until you're ready to perform that cutover. Last but not least is the database migration service that we offer through Azure. And this is a great tool because you can actually monitor the progress of your migration using the Azure portal. So we definitely recommend that as the go-to option for online migrations. And once your data has completely migrated into your flexible server, you're going to want to do a couple things. First, run a bunch of functional tests and actually validate that all that data has made it completely over into Azure. Next, you want to update any connection strings that you have for any apps that are connecting to your previous server to now point to that server hosted in Azure. And so like I mentioned earlier on in my demo, the burstable compute option is now available for flexible server. And this is really great because it's a lowest pricing point that we have available for the flexible server deployment option. And we support up to 1 to 2 vCores. What's also great about the burstable tier is that we support all features, and that includes premium storage as well as VNet integration. Previously in single server, you may have seen some of our features lacking in the basic compute tier. And so what's also great about burstable is that you can actually bank up credits. So if you're not familiar with burstable CPU credits like we have in virtual machines, the same applies for the deployment option here with flexible server. And so you can bank up your CPU credits to be applied to reach up to 100% CPU whenever you need that peak. And so now you've learned a bunch of different things that we've explored with Flexible Server and the new innovations we have available. And if you have a single server, you might be wondering, well, what's the difference and when do I use a single server or Flexible Server? And so first, if you really care about using the latest version of Postgres 12, I definitely recommend, and we push you to use Flexible Server in preview because that's where you can get the latest Postgres version. And MySQL 8 is indeed planned for Flexible Server as well. And so if you have an application that needs zone resiliency, definitely use Flexible Server because we have that zone redundant HA introduced with Flexible Server. And if you need more fine-tuned granular control of when deployment and maintenance happens on your particular server, we recommend using Flexible Server because you can control all of that through a custom schedule. And if cost optimization is something that you really care about, definitely consider using Flexible Server in the stop-start functionality. As well, point-in-time restore is also supported for both of these services. And network isolation is provided in both of the deployment options, with VNet integration being what we've highlighted here today in the Flexible Server preview. And if you have a few features such as custom managed keys or bring your own key encryption, reserved instances, or cross-region replicas that you need to use today, then definitely consider using single server. Also, if you have a production workload that needs to be moved over into Azure Database for MySQL or Postgres, consider using the single server option because that is what has a 4.9 SLA today. The Flexible Server, while it's in preview, does not have an SLA, but that's something that we're going to have when we move to general availability. So now I wanted to leave you with a bunch of links for you to get started. The first is definitely visit our documentation to learn about how to create your very first Flexible Server. Next, read up on our launch blogs, which we highlight some of the great features that we've introduced with Flexible Server. And then I also wanted to highlight a couple great customer stories that we released. Like Lucas mentioned, we have the Cloud9 customer story. You should definitely read up on how esports are using Postgres, as well as how one of our great MySQL customers, 10th Line, is using MySQL on their workloads. And lastly, if you need to reach us, definitely email us, and we do our very best to email you as quickly as possible. Now let's move over to some Q&A.
Perfect. And we got a few questions here. The first question is, so I noticed the VM names look familiar. Does this new service use the public compute VMs?
So yeah, we're actually using the public VMs available through Azure VMs, and we've really done a lot to simplify our architecture. And so what this does for you as a customer is all the VMs that you're already familiar with, you can definitely see within our service. And we're using B series, D series, as well as E series.
Perfect. Another question here was, so I received an email recently about a certificate change for the single server offering, and what does that mean exactly? Like, what do I need to do? And I can actually take that question. We currently, for the single server offering, we sent out an announcement about certificate change that's upcoming. We have details in our documentation, but really, if you're using the full CA verification or verify full modes for the Postgres or MySQL options, then just make sure that you're updating your certificates. If you're using app service or other kind of managed services that run the application for you, then usually you don't have to take any action. But the documentation for our services has exact details on what you need to do for that CA rotation. All right, and then we had one more question here, and that question was on, let me see. So on tuning max connections. So can I tune the max connections?
Yeah, you definitely can, and we have a bunch of great documentation. I'm going to flip back over to the resources slide, and you should definitely check out the first line where we point to the documentation, because you could learn more about how to change your server parameters in the Azure portal or the Azure CLI. All right. And with that, I just want to close out. So on behalf of myself and Lucas, we wanted to thank everybody here for joining us today for this session. We really appreciate your time, and we hope everybody's staying happy and healthy. Thanks again.
Thank you.